All right, let's just jump right in. Sometimes the biggest, most mind-blowing questions about reality don't start in some billion-dollar lab. Sometimes they start with something that's literally in your hand right now.
And I mean a really simple question. The kind of thing you'd probably just dismiss. But if you actually chase it down the rabbit hole, well, you end up questioning pretty much everything. And there it is. That's the question that kicks this whole thing off. Think about it. Your headphones, your mouse, your car, they're all connected by Bluetooth. But have you ever wondered about the physical size of that wave? Seriously, what's your guess? A millimeter? Smaller?
The answer is about 12.5 centimeters. Yeah, that's about the length of a brand new pencil. It's kind of wild, right? These signals aren't some microscopic sci-fi energy beam. They're big. This description just nails it. It's the perfect way to picture what's happening. Right now, as you're sitting there, your room is literally full of these invisible, forearm-sized waves just sloshing all around you. But that classical picture, that's just the tip of the iceberg.
So when we zoom all the way in, from our everyday world down to the quantum realm, things get really, really weird. I mean, how does a single photon, the tiniest possible bit of this wave, have anything to do with that 12.5 centimeter size? And that question drops us right into the middle of one of the biggest arguments in modern physics.
So welcome to what some people call the quantum swamp. For the better part of a century, physicists have been battling it out over two totally different stories about what's really happening at the fundamental level of our universe. Okay, so on one side, you have the mainstream idea, quantum field theory, or QFT. It says the only thing that's truly real is the field itself. Particles? They're just little blips of energy in that field, kind of like a ripple on a pond. Then, on the other side, you've got pilot wave theory. It says, nope, there's a real tiny particle, like a little marble, and there's a separate wave that tells that particle where to go. So QFT is all about probabilities and chance. Pilot wave theory gets rid of the randomness, but to do that, it has to add this extra ghost particle we can never actually see. It gets complicated. But what if this whole debate is a false choice? What if we don't have to pick one? What if we could take the field is everything idea from QFT and combine it with the clear, no randomness allowed world of pilot wave theory? And that question leads us to this really powerful, unified way of seeing things. A way that doesn't need any randomness and doesn't need any weird, invisible ghost parts. The idea is called deterministic field realism, and the core concept is actually pretty simple. The only thing that exists are fields. The electromagnetic field, the electron field, all of it. They're not just handy bits of math we use for calculations. They are the literal physical stuff that the world is made of. So, if that's true, what's a particle, like an electron? Well, it's not some separate little ball of something. It's just a stable, concentrated knot, a little lump of energy in the field itself. The best analogy is a whirlpool in a river. That whirlpool isn't separate from the water. It is the water, just, caught in a specific self-sustaining pattern. And here's the real kicker. There's no need for a separate pilot wave to guide anything. The field's own internal structure, its energy flows, its phase, all of that is what determines how these lumps of energy move around. The thing that's guiding and the thing being guided are the exact same thing. It's a totally self-contained, deterministic system. No ghosts needed. Okay, but that brings up a pretty huge question, right? If everything is just one continuous field, why isn't it all just boring, uniform soup? Why does energy bunch up into these stable lumps that we call particles in the first place? Well, it all comes down to the field's own internal rules. First, something called nonlinearity. Basically, the field influences itself, which lets it focus its own energy. Second, you get this perfect balance between the field's natural tendency to spread out and this self-focusing force that pulls it inward. Third, you've got these little currents of energy that circulate locally, which reinforces the lump and keeps it stable. And finally, different fields can link up and act like a kind of glue. So it's not magic, it's just physics finding a nice, stable balance. So here's where things get really fun. Once you start to see the universe this way, as this single, continuous fabric where everything is connected and causal, a lot of classic sci-fi starts to look less like fiction and more like a really, really hard engineering problem. Let's just go for the classic, the transporter. Could you actually beam someone from one place to another?
In the standard quantum view, with all its randomness, it's a philosophical mess. But in a universe of deterministic fields? Well, the physics says yes, it's possible. You're not actually making matter disappear. You're just reading the entire, incredibly complex field pattern of a person, every single particle, every bond, and then using raw energy to perfectly recreate that exact same self-sustaining pattern somewhere else. So it's not magic. It's just an engineering challenge on a scale that is almost impossible to comprehend.
This view also neatly solves that old teleporter paradox. What makes you, you? It's not the specific atoms in your body. Those are getting replaced all the time anyway. It's the pattern, the dynamic, self-sustaining arrangement of fields that is you. So if you recreate that pattern perfectly somewhere else, there's no copy and original. The process is just continued in a new location. It is you.
Okay, this is a really cool story. It's a great philosophical framework. But is that all it is? A story? Or can we actually test this? Let's bring this whole idea back down to earth and see if it holds up in the lab. Oh yeah, you can absolutely test it. See, if particles really are just stable lumps in a field, then the theory makes a very concrete prediction. You should be able to carefully pump energy into a field, and once you cross a certain threshold, poof, a lump should condense out of it. And you should be able to do the reverse too, dissolve it right back into the field.
And the best part? You don't need a giant particle accelerator to see this happen. This right here is a shopping list for a simple tabletop experiment that's a perfect analogy for particle creation. For maybe 150 pounds tops, you could build a circuit in your garage that shows this core mechanism in action. And when you run this experiment, you see three things that line up perfectly with the theory. 1, nothing happens, and then, bam, the second your energy pump crosses a very specific threshold, a stable oscillation, your particle analog, just appears out of nowhere. 2, its properties are perfectly locked to the signal you're pumping in. It's completely deterministic, not random. And 3, if you turn off the pump, it predictably and smoothly dissolves right back into nothing. So what this all points to is this. Maybe the strange, probabilistic world of quantum mechanics isn't the final story. Maybe it's just our blurry, incomplete view of a much deeper reality. A reality that's continuous, that's causal, and that just unfolds according to its own internal logic. The universe doesn't roll dice, it just runs. And that, of course, brings us all the way back to us. Because if this view is right, then everything you are, your consciousness, your memories, your entire identity, is just an incredibly complex, stable pattern in this one cosmic field. A pattern that's totally unique, but made of the exact same stuff as everything else. Which leaves us with one last thing to chew on. What exactly is it about your pattern that makes it you?